Assalamu alaikum. My name is Moaaz Ahmad. In this video, I am going to explain the lab number 13 of our DLD lab subject. So, in this lab, we are required to implement circuits of register and counters. The main objective of doing this lab is to learn how register and counter actually works, and moreover learn the working of both of these objects by implementing a 4-bit register and a counter circuit on soft breadboard. Through this lab, we can also get a basic concept of memory storage. So let's move forward to our first task of this lab. So our first task for this lab is to design a synchronous up counter. So as you can see right here, this is the diagram of our circuit that we are about to design. So to design this circuit in the Proteus lab, I have already created a project in the Proteus. So in this project, I'm first going to add all of my required components from these libraries. So the first, as you can see from this diagram, that we need 4 flip-flops and 2 AND gates for start. So I will go to my Proteus file and I will select here, and first I will add the flip-flops. So I will say 7476 and I will add them. And the next thing I need is AND gate, so I will type the number and add them too. And the next thing I need is logic toggle for input. So that's it from all of our devices. So now the next thing I want to do is place all of these components in my sheet. So first I will select the flip-flops and I will add them right next to each other. Okay, now I will take out the 2 AND gates and I will place them one right here and other one right here. Let me move this a little bit downward, and also this the same way. So now I will place the logic toggle here in the start and I will connect it with 16 pin of this flip-flop, and I will connect it to the 4 number pin, and then I will make the rest of the connections like I will connect both of these, sorry, not this one, the 14 pin of this to 12 pin of the second one, and then the 9th pin to the 12th pin. And now I will connect the 14 pin again to the input of AND gate right here, and I will connect the 10 pin of this flip-flop to the pin number 1. And the next thing I want to do is add the remaining connections. So I will connect the number 4 pin of this circuit to the number 16 pin, and I will connect the 16 pin to the number 3 pin of this AND gate, and I will connect number 3 to number 5, and number 4 will go to the number 14 of the third flip-flop, and number 9 of last flip-flop will be connected to number 12, and number 6 we will come back to it later on. And the remaining connections are the 6 pin, 1 pin, 6 and 1. We have done all of the other connections. So to get our output, the next thing we need is an analyzer, logic analyzer. So I will go here, instrument mode, and I will select the logic analyzer here, and I will place it right here. Now I will connect all of the output pins from these flip-flops to each one of these inputs. So I will connect A3 to number 15 pin, and number 11 pin will take over the A2. So number 11 will take on the A2, and number 15 of first flip-flop will go with A1. Now I will go here in my generator mode, so generator mode, right, and select the D clock here, and I will place it right here so that we can get values from here, and I will connect it with the pin number 1 of this flip-flop, and then I will connect it again with the pin number 6 right here, and the next connection will be of number 1 pin of the third flip-flop right here, and the last connection with flip-flop will be of number 6 of the last flip-flop. And now I will connect A0 to this D clock, and our circuit is complete. Now I will change this value to 1, and I will click play. So our circuit is working, as you can see from right here. If I zoom in a little bit, as the clock moves on and on, these lights A1, A2, A3 and A4 lights represent the binary numbers up to 4 digits. So as you can see, A3 is on, and now A3 and A2 and A1 is on, which means that it is representing the number 7. And now since A4 and A3 are on, this means it is representing the number 12. And now it starts again. A1 means 1 and A2 means 2. So that's how it works. So that is from this circuit. Now let's move on to our second circuit, which is, if I open the PDF right here, our second task is to design a synchronous down counter. So this is the block diagram from this counter, from this circuit. It is pretty much common to our first task, but we just have to modify the first task a little bit to get our second task done. So I will go here in my first task circuit, and I will change some of these values a little bit, like I will remove the 14 pin connection to 12 pin connection and 9 pins connection to 12 pins connection, and I will connect the 9 pin to 15th pin, and then I will remove this connection right here, and also remove this one, and then I will connect the 4th pin of this AND gate with the 15th pin, and I will connect the pin number 1 of this AND gate to the 11th pin. So that's pretty much the circuit we are required to design. So let me just again check to confirm. Yeah, this is the circuit. So I will run the simulation, and now you can see that it is working exactly how we want it to work. I will just wait for it to reset to the previous value, to the first value. So this is our lab number 13, and our both of the tasks have been done and they are working properly. So that's it from this video. Until next time, Allah Hafiz.